Hello everyone. Today we are going to make a magic sphere effect. It has a complete cycle and can be used as aura effect around our character. Of course, we can also set its size, color, duration, etc. to make it more suitable for the custom characters in our project. Since these assets are provided to us by Unreal Engine for free download, we will no longer create these meshes, materials and textures. I will put them all on my Patreon for everyone to download for free. Okay, let's create Niagara directly. Generally speaking, if we want to make a complete cycle of an object, we will use 3 emitters to control the spawn, loop and close, just like a portal. So we first make the sphere spawn, add mesh renderer, use the mesh and material in the asset, and set lifecycle mode to self, loop behavior to once, which is also the basic setting for a one-time effect. Then add spawn burst, spawn count is 1, so that we can see the sphere in the preview. Next is the lifetime. We set it to 0.3, because it only controls the process of sphere spawn, so its lifetime doesn't need to be too long. The color still uses the linear color in the user parameter, and set default color to red. As for the mesh size, we can keep the default. In the particle update, add scale mesh size, use vector from float and curve from 0 to 1. Here we can set key data to a larger value at 0.5, then return to 1 in the end, so that the change of the sphere will look more tense. Then scale color, still use vector from float and curve. Here we use template curve, scale curve set to 5. The value at the end is 0.2. Alpha here we also use a curve from 0 to 1. Okay, so the process of sphere spawn is completed. Next, we make the sphere loop process, directly copy this emitter. Because in the loop process we have to manually set its duration, so in the lifecycle for loop duration, using the user parameter float, the duration we set manually add the time it takes for the sphere spawn, which is 0.3. Then set its lifetime to user duration. Yes, it should have a default value, such as 2. Then we don't need the scale size and color of the sphere during the loop. Just keep it at the default of 1. Or we can just delete them. Then add update mesh orientation to make the movement of the sphere more random. Random axis and set rotation rate to 0.1. And we also need to control its spawn time. We can't let this emitter and sphere spawn trigger at the same time. It should be spawned in an orderly manner, so set its spawn time to 0.25. Yes, now we have a spawn and loop process. We can control the duration of the loop, longer or shorter. It's all right. Then we make the process when the sphere end. This is very simple. Just copy the emitter, sphere spawn, and set the curve in scale mesh size to the opposite. The color can be modified appropriately, but make sure the starting value here is consistent with the color end value in the sphere loop emitter. Also, we still need to set its spawn time and loop duration. Using user duration, add the time spent at the beginning and end, double 0.3, which is 0.6. Then the spawn time is also after the spawn and loop process. Use user duration, add 0.1. Now let's take a look. We will find that the rotation of the sphere is inconsistent at the end of emitter sphere loop. This is because we update mesh orientation during sphere loop. So at the end we need to get the update mesh orientation. Here we can use a custom module to get the updated orientation of the mesh. Use particle attribute reader to get the parameter in other emitters. Then add get quaternion by index. Because we only spawned one particle, the particle index is always 0. Finally, The output value is connected to the particle mesh orientation. Don't forget that attribute requires inputting the name of the parameter. We also need to copy the name of the emitter so that we know which emitter to read the parameters from. Okay, now we can see that the orientation of the sphere at the end is consistent with the orientation of the mesh during the loop. That's a complete cycle process. Let's rename this module. And we can add other visual effects to make sphere looks better. Add sphere glow. It also needs 3 emitters to control different process. These settings are almost the same as emitter sphere. Use mesh and material in asset. Set lifecycle mode to self, loop behavior to once, spawn count to 1, lifetime to 0.3. Color is also user parameter. And mesh size is 0.3. In this way, we can see there is a glowing effect on the edge of the sphere. Maybe 0.31. Okay, as for scale, mesh size and color, just copy them directly. This completes glow spawn. Now to make its loop, we can copy some modules and parameters in sphere loop. First of all, the parameters in lifecycle and spawn time, lifetime. No need for scale, color and mesh. Of course we don't need update mesh orientation. We will set its facing mode later. Oh, in fact we can add scale color. Dynamic color changes are always good. Finally, change its facing mode to camera position, so that the mesh is always facing the camera position. Okay, this is glow loop. Finally, we will make glow end. Just copy glow spawn directly, rename it to glow end, then find sphere end. All the parameters are the same. Here there is no need to update mesh orientation. That's right. Next we can add spline and spark. First add spline to make the ribbon effect around the sphere. Still use mesh renderer, mesh and material. In this emitter we use spawn rate, so the loop duration will be lower. It is strange for these splines to continue to spawn when the sphere effect is end. So set the loop duration to user duration, add -0.5, and spawn rate to 10. Then set lifetime to random value, 1 to 1.5. Color still uses user parameter. Mesh size uses random non-uniform, 0.4 to 0.5, so we can see the spline around the sphere. Then add initial mesh orientation, set a random rotation. Of course, we also need update mesh orientation. Use random vector to rotate the spline around a random axis, set the rotation rate to 0.2. Then add scale mesh size, again using vector from float and curve. The value doesn't need to set too obviously, 0.8 to 0.9 is fine. And a dynamic material parameter here. One is random offset, the other is ribbon width. Random offset we can directly use random range to set 0 to 1, ribbon width can use a curve from 1 to 0. Set the value to 1 when the key data is 0.5, and the value is 0 at the end. OK, then scale color, use the template curve. Scale curve set to 5. Scale alpha still uses the template curve. If we think the color of the spline is too bright, we can change the alpha to 0.5, so it will look better. Finally, add spark. It's similar to emitter spline, but we need to control its duration. The duration of spark can be longer, because usually there will be some spark residue after the whole effect is over. So set the loop duration to user duration, add 0.5. Set the spawn rate to 300. Lifetime is 0.5 to 0.8. Color is still user color, and there is a random sprite size. Minute value is 0.5, max value is 1 to 2. Select random rotation. Add shape location. Sphere radius set to 30. Then add scale color, which is the same as before. And some forces, such as curl noise force. These parameters we can adjust freely. Also linear force or acceleration force, a random value, mainly to control the upward movement of particles. And drag, using a curve, a drag that gradually increases from small to large, so that the particles look better with the movement in reality. Finally, we can add scale sprite size by speed. 0.5 to 1. Velocity threshold is 500. And set sprite renderer to face camera and velocity aligned. OK, let's take a look in the level. Yes, that's it. It looks very good, so we have created a magic sphere effect. Next, we use the simplest way to make it around the character. First, create a new Niagara system, and rename it around. Here we use component renderer. Select Niagara as the component, so we can select the magic sphere we just created. Set the number of spawns to 3, change it to once. Then add shape location, only spawn on the surface of the sphere. Finally, just add vortex velocity. It should be noted that this module is only available in UE 5.3 and below. If we were using UE 5.4 or 5.5, we will need to create a similar module myself. Set the random axis and speed. OK, add it in the level. We can see that mesh sphere does not move with spline and spark. This is because emitter sphere and glow use spawn burst, not spawn rate. So its position won't be updated. We can set the sphere and glow to local space. In this way we get the effect of the sphere surrounding. And we can control its duration in Niagara. Okay, so that's all for this video. I hope you like it. Bye.